Welcome back. These are the notes for Algebra 2, Chapter 5, Sections 8 and 9. This is Part 3. We're looking at the checkpoint near the bottom of page 2 in the notes. Here we're given a polynomial function in factored form, and we're meant to graph the function. Now, because it's in factored form, we already know the zeros are x equals 2, x equals -1, and x equals 1. And so that means that the x-intercepts are at 2, 0, -1, 0, and 1, 0. There we go. So we can go ahead and graph those. We have 2, 0, -1, 0, and 1, 0. Let's see here. Now that we've graphed the x-intercepts, we need to go ahead and find some other point values nearby those. Let's see here. The x-intercept on the left is -1, so maybe we should try a little bit to the left of that. So we should go ahead and try x equals -2. Well, if you substitute in -2, you're going to get -24. -24 is just simply not happening on the graph. What about f of 0? If you substitute in 0, you'll get 4. Well, 0, 4, that is a point we can work with. There. X equals 1 and x equals 2 are both x-intercepts already. We could go ahead and try substituting in 3. If you substitute in 3, you'll get 16. Again, that's just not happening on the given grid. So, pretty much we have all the points we can get for this one. We now need to worry about end behavior. That will give us the arrow direction. With the arrows and the points, we should be able to make ourselves a graph. So, this is a polynomial function with 1, 2, 3 factors. So it's a cubic function. And because it has a 2 in front, it has a positive leading coefficient. Because it's a cubic function with a positive leading coefficient, we know the arrows are going to go like that. Remember, the fact that it's cubic means it's an odd power function. And an odd power function with a positive leading coefficient falls on the left, or it goes to -infinity on the left, and it rises on the right. So it goes to positive infinity on the right. Well, with that information, we can go ahead and toss in the arrows. Now, you'll notice I put the arrows pretty close to those points, and that's because we know that f of -2 is -24, so it has to fall off of the graph before the x value goes to -2. And then likewise, f of 3 is 16, so it has to climb out of the graph before the x value gets to 3. If you look back at the function, all of the factors are linear factors. None of the factors are squared or anything like that. So that means that the graph acts like a line when it's passing through them. And that happens at -1, that happens at 1, that also happens at 2. You might wonder how we figure out exactly where the graph turns around as it goes from going up to going down or going down to going up. The answer to that is twofold. You can either use a graphing calculator and ask it to do that, and the graphing calculator uses calculus to accomplish that, or you can just learn calculus to do that, or, and this is what's most important in Algebra 2, you can just not care about that. Here we have the checkpoint. We've made a graph. We used the factor information to create x-intercepts. We plotted one more point. There was an attempt to plot some more, but the points would not cooperate. We looked at the degree of the function and the leading coefficient to determine end behavior. We've got ourselves some arrows that are appropriately indicating the way the function is going. And in fact, we have ourselves a marvelous solution to the checkpoint. Thank you.